All right, energy. Wow, we're going back almost 2,000 years here. Roman energy crisis. The Greeks were amazing. They did so much to uh, improve our society with the ideas that they came up with. They were, remember, the very first ones, and we'll learn more about this later this semester. They built the first water system, the first sanitation water system, allowing for clean water to come into their cities and dirty water to leave. And that's such an important aspect of life expectancy. Having clean water, they were able to double the average life expectancy. Their main source of energy was wood, biomass, which obviously we kind of use that for pleasure in this day and age, right? If we go camping, we build a fire out of wood. I lit up a couple of fires over the break. We have a wood fireplace. And I like the smell and the crackling, right? That's all part of it. But for them, it kept them alive. What they would do is they would go out to the edge of the city where the forest was at, and they'd cut down trees and chop up wood and they'd burn it. Well, you can imagine as their cities grew in size, as they do with urbanization, even 2,000 years ago, they had to start going further and further away to find firewood because they had depleted all of the close sources. They were starting to run out. And so eventually it became a real hassle. They had to go a long way away to get enough firewood to bring back. So that to them was an energy crisis, the fact they were running out of firewood that was nearby. They also recognized that the sun actually is a source of energy and an important one. And they passed the very first, I would call it the very first environmental laws. They made it so that buildings could not cast shadows on other buildings. You had a human right to have sunlight hit your property. That's pretty cool. And you look at, we're going to learn about something called passive solar energy. And it's on display in this picture. Once again, it's something the Greeks understood before anybody else. If you look at this picture, the sun is clearly shining down on that side of the building. And look at all the windows. They are pointing that direction so that they maximize the amount of sunlight that gets into that building. The architects designed it that way. When you eventually buy a home, which I totally do not recommend, don't get married, don't buy a house, don't have kids, just throwing that out there. If you eventually buy a home, you want to think about that. It's something that I stupidly screwed up when I purchased my home. I have 0 windows on the south side of my house. And living at the latitude that we do, that's where all the windows should be. They should be on the south side of your home, or the southwest if your home is at an angle. So that sunlight is so important and can really cut down energy costs. Notice that in front of this building, they have a public bath. The public bath was also put on the side of the building that gets the most sunlight so that the water would heat up each day. You know, it's pretty common sense stuff, but it's really brilliant design. Energy is such a vast topic, which is why we're going to spend 8 weeks on it. But we can start off by looking at how do we consume energy. And you can see that over the last 200-300 years, it was all wood before, it was biomass until the Industrial Revolution. And then it was the discovery that we could burn coal. The carbon in coal, the bonds between it, when combusted, release energy. This is the Industrial Revolution right here, this giant exponential growth of burning coal, which we know is one of the major causes of what we're calling climate change. And then we figured out, oh, there's oil down there too, and we can use oil. And so petroleum quickly passed up even coal. And then there was, we figured out how to get natural gas more efficiently out of the ground. Fracking is, you've probably heard of fracking, I hope, hydraulic fracturing. It's not new. We just have gotten much better at it the last 2 decades. But hydraulic fracking goes all the way back to the early 1900s. And so around 1940, 1950, that we got a lot better at it. And that's the spike you see. So the top three that we use, and we're going to learn tomorrow about these quadrillion British thermal units. I'll teach you all about the units tomorrow. But you see that the top three are fossil fuels. We consider these to be non-renewable. Non-renewable means that we use them faster than they can be replaced. And these are the ones that cause all the pollution and are causing all the global warming. So obviously, with the green revolutions, we are wanting to increase our usage of things like, well, most people would say, I don't want nuclear either. It's got its own problems. But things like wind and solar. But look at it, they're so small. We're barely using them compared to all the others. And the reasons are simple. It's easier to get coal and gas than it is to collect wind and solar. It's cheaper, way cheaper. And part of that is because our governments are propping up the fossil fuel industry. They subsidize them. They make it easy in terms of regulations. The fracking companies do not have to disclose the nasty chemicals that they shoot down into our ground. They don't have to tell anybody. It's a little loophole that the politicians passed. So they're getting away with destroying our planet because it's cheap and easy, and we all crave energy. Remember, this whole curve that you see is totally tied to the Industrial Revolution and the demographic transition that we learned about first semester. Well, this is one of those stats that's going to make you feel terrible, and honestly, we are part of the problem. We are privileged. We're all sitting there, and I'm seeing those of you with cameras on. Your rooms all look nice. Some of you have pretty lights around the corners of your rooms. My daughter, that's what she wanted for Christmas. She's 12, and all of a sudden, that was really important that she get LED lights to go around her room. But look at this. The US makes up 5% of the humans in the world, yet we use a quarter, 25% of the energy. We are energy hogs. The only country that uses more than us is China. And China has way more people than we do. And then we look at how the sources of our energy, things like coal and oil and gas, it is not evenly spread around the world. We have to import and export, and that's all driven by money. Part of our energy usage is controlled by the cost of energy. And so you see that in the United States, we do have abundant coal. We have a ridiculous amount of coal compared to other parts of the world. The only place that has more coal than us is China. China has as well a gigantic amount of deposits. And why is that? Well, it has to do with geologic history. The fact that a lot of the United States used to be wetland and swamps, and it goes through something called uplift, and it dries out, and all that swampy material decayed and formed coal. But that didn't happen in other parts of the world. When we think about plate tectonics and how the mountains were thrust up down the coast of South America, that's not ideal for forming coal. We see that oil is dominant in the Middle East. That's been a question on the AP exam before. You know, where are these fossil fuels found? The Middle East is oil and natural gas. The United States and China is coal. And once again, it's all because of our past geology. One of our biggest issues in the United States is transportation. You'll see in just a minute that we use about a quarter of our energy needs just for driving places, getting around, flying. And so the easiest way to do that is through oil products, gasoline. And so we are the world's leader in consumption of petroleum products, oil, gas, so on. China is actually catching up to us. This is older data, and China is closing that gap. So it's the US and China who are the biggest consumers of, once again, these fossil fuels that are damaging our environment. It's not all doom and gloom, though. We are seeing trends that are just like our population, which is experiencing logistic growth. We see that our electricity usage is experiencing a plateau as well. And it's hard to say if this is going to go up or down, but as new technologies emerge, we're finding ways to use our energy sources more efficiently. So it's not that we're actually using less because we have more people, but we just don't need as much as we used to because we have more fuel efficient vehicles. We have light bulbs that require way less energy. And we finally started to attack some of these big corporations who waste energy. And that's really where we need to target. And that's going to bring our electricity usage down. Okay, so you don't really need to know any of these numbers because it's more simple than that. We divide our energy usage into what are called sectors in the United States. And we're going to come back to this probably tomorrow. And there's four main sectors, four places that energy use is organized into. So in the United States, it's driving our cars around, flying to awesome vacation spots. We have our homes. We have our stores, all the places we shop, all our commercial properties. And our biggest chunk is industries, making steel, any type of manufacturing obviously requires a lot of energy. So transportation, which is mostly oil, and industry, which is mostly coal. These are our two biggest fossil fuel hogs. We are figuring out how to use wind and solar to knock out these two sectors, residential and commercial. We're getting better at that, but it's transportation and industry that are the true problems. Now, I said you didn't need to know numbers because if we round, they're all about 25%, right? It's basically a quarter each. Yeah, commercial is a little bit less, but really they're pretty even, which just contradicts everything I said. Oh well. I can't count the number of times that I harass my girls to turn off the light. Hey, you left your lights on in your room. Oh my gosh, you left the TV on. You're not even watching it. It is constant in my house. I'm the only one who cares because I'm the only one who pays the bills and sees those numbers. It really does add up, the tiny little things. There's a pet peeve I have that drives my family crazy. And that's, I'm sure a lot of you do this. If you have a charger for your phone, my daughters are always leaving them plugged in. Do you leave your charger plugged in every day? Pull your phone and just leave it plugged? You shouldn't do that. You're wasting electricity. Great job. You're ruining the environment. So I always harass my girls, unplug your chargers. Don't leave them plugged in. Somebody DM'd me, I just unplugged my charger. Yep. Now, is it going to all of a sudden drop your parents' electric bill by $20 a month? No, we're talking pennies. But there's 300 million people in the United States. There's probably 200 million phones, probably way more than that. If we have 200 million chargers plugged in, we're wasting a lot of electricity. The easiest way to deal with leaving things plugged in, because it is a pain plugging things in all the time and unplugging them, power strips are great, right? You can turn that on or off, and that then stops the flow of electricity. So power strips are the way to do that. Or you can plug a bunch of things into one and unplug just one plug. I know, we're spoiled. It's not always convenient. Here's what everything really boils down to. Technology has allowed us to be more efficient. It's all about efficiency, which I've already brought up. Like cars have become more fuel efficient. Light bulbs are way more efficient than they used to be. And you guys do need to know how to calculate efficiency. And we went over this first semester. So it's output divided by input, right? How much electricity goes into the bulb and how much energy do we get out of the bulb? It's never 100%, is it? We can't get 100% out. And the reason why is the second law of thermodynamics. So efficiency tells us that some of the energy is going to be lost. I talked about waterfalls yesterday, and that tremendous power that comes over the cliffside. Well, it's really no different than a dam, right? We're using gravity to pull water through a turbine to create electricity. And it's not 100% efficient, but it's pretty good. We don't lose much to friction. That's one of the biggest places we lose energy in transformations, friction, which in turn produces heat. Heat is our true biggest loss during an energy transformation. There are two laws of thermodynamics that are important to us. The first law says that energy can change forms. Energy can go through transformations. That's hugely important and will tie into tomorrow's lesson. So an example is you eat food, that's chemical, and your body then converts that through your muscles into kinetic motion. Food gives you the ability to do work. That's what energy is. We can take solar energy, and through photosynthesis, it becomes chemical energy. Remember GPP and NPP, gross primary productivity and net primary productivity. So some of that is lost because of respiration. We can take gasoline, which is a chemical, and we can combust it, which gives off heat and exhaust. That's the waste. But it also creates the gases that we need to drive the pistons in our cars. So we turn chemical into kinetic as well. If you have an electric stove, it can turn electricity into heat, thermal. Lots of different transformations that humans have figured out. The second law of thermodynamics is the first law of efficiency. And the first law of efficiency just says some of it's going to be lost. It's the same law, just with a different name.
That's like a really inefficient way of making.
The irony is amazing, isn't it? An inefficient way of describing efficiency. Yes. Hilarious. All right. So what was it? Edison invented the light bulb. So he figured out that you could pass electricity through what we call a filament, which is just really an element. And if enough electricity goes in, it will get hot and glow. That's all an incandescent bulb is. He discovered that one of the best elements to use was something called tungsten. Tungsten works really well because it can get really hot and glow really bright, but not burn through itself. That's why they last a long time before they finally snap and break and you have to replace your bulb. But incandescent bulbs, which most people prefer because we like the quality of the light, we like the color of the light that it gives off, mainly because we're used to it. That's what I think. The bulbs get really hot. You can get burned, right? And that's because they're only giving you about 10% of the light, of the energy that's coming into the bulb. Only about 10% of it turns into light. And 90% of it is wasted as heat. So along came the invention of fluorescent tubes, and like the ones we have in school. What's inside of these are gases, and the electricity causes the particles to bounce around fast inside of the tube, and they collide with each other and they glow. It's much more efficient, but the quality of the light's a little different. Not everybody likes compact fluorescent lights. We just shaped them like normal light bulbs so that we could replace incandescent with fluorescent. If you use CFLs at home, they have mercury in them. So you should not put them in your regular trash. You're supposed to save them and take them to hazardous waste. Now, the good news is, like I said, CFLs were never that popular, and most people have switched to what we call LEDs. LEDs are way more efficient. They're incredible technology. 80%, look at that. They're called light emitting diodes. And that's plural, diodes, because there's a whole bunch of these tiny little superconductors inside. And when electricity hits them, they glow very bright. They don't get very hot. And they just cram like 20 or 40 of them inside of a bulb. Once again, they shaped it like a normal light bulb. Or they put it, I see some of you with the rope lights behind you. You can put LEDs in any shape you want. We were at a museum a couple summers ago, and that first one was an incandescent bulb. Now we've got a CFL, right? The same amount of cranking of the dial, you can see the LED is by far the brightest because it doesn't take as much energy to light it up. Way more efficient. there is a second law efficiency, which basically answers this question. Are we using the right type of energy? We use gasoline in our cars, but could we power our cars with coal? Absolutely, we could. It would be dirty and it wouldn't be very efficient. We did it before, early in the Industrial Revolution. That's how we powered vehicles, trains. We pumped coal into a furnace, created steam, and that's what drove the engine. But then we discovered gasoline, which combusts in much more efficient explosions. So, which is more appropriate and more efficient to use for the transportation sector? Obviously, gasoline over coal every day. So I thought about this example, right? We don't use a blowtorch to light up a birthday candle, but we could, but that would not be very efficient, right? When I first put this presentation together, I knew I wanted a picture of somebody lighting something up ridiculous with a blowtorch. And I searched all over the internet, which I'm pretty good at, and I could not find a picture of somebody doing something dumb like that. And I tried every search I could think of, and eventually, it hit me, and I Googled redneck birthday, and it came right up. Unfortunately, I saw other things that I never want to see again. So I don't encourage you to Google redneck birthday. Hillbilly birthday might work too. Maybe that's less offensive than redneck. But I found somebody lighting up a tub of ice cream with a blowtorch. All right. One last thing to show you today. I know that lesson kind of went long. This is, once again, a total misuse of second law efficiency. This is not a great idea. But this man, this engineer, built a 20,000 watt light bulb. 20,000 watt light bulb. Why? Because he could. So here he is. If I can get it to play. Here is his 20,000 watt light bulb. Boy, I bet the neighbors love him. Because see, it's pretty big. Look at all the filaments inside. And here he is cranking up the wattage. It's literally blinding. There's what it looked like outside of his house. The whole neighborhood lit up. Unbelievable. All right, that's all I have for you today. We'll continue talking about energy tomorrow. Have a good one. Bye-bye.